Hello, everyone. Good evening to all of you. So, today is the last session that we would like to have, and would like to cover AHP and EVA. So, I'm going to start briefly. What is AHP? AHP is, let me share the screen and then uh, starting the session. So, just a minute. Can you see my screen?
Yes,
Okay, perfect. Thank you. So, AHP is analytical hierarchy process. And this is a multi-criteria decision making technique. So if you come across various situations where you are in dilemma to choose this or that, or you are selecting, let's say you are selecting a boss or you are hiring an employee, someone is good in something, someone you want to hire one thing, one person you want to hire other, who is the best? You have five to five cars in front of you. One car is good in reliability, another car is good in mileage, another car is good in style. Which one to buy? So this is a dilemma. We want to buy a house. When we want to buy a house, which is our first preference, which is second preference? So in such kind of scenario, we use AHP. It's called analytical hierarchy process, where you have multiple criterias to evaluate each options. And actually, this is the simplest form. There's a analytical network process. So that is called ANP. There's a fuzzy AHP. There's a fuzzy ANP. So there are various versions of this technique, but we are covering basic for this module only. We are not going to have in the exam. So just finish your exam and will be fine. So let me starting very very first step. For example, you want to buy a, or goal is right here. You have different criterias and you have different sub criterias, or and you have different options. So instead of that, let's go and do very simple thing. Another important aspect about this is a mix of qualitative and quantitative. So first you decide qualitative factors and then you decide quantitative. How you can decide the quantitative? So start with the pairwise comparison. Pairwise comparison, let's say, so this is, let's say, hierarchy. Here the objective is, you can interrupt me anytime if you don't understand. Let's say your objective is to buy a new car. Buying a new car, you have different criterias. Style is one criteria, reliability of the car is another, fuel economy or mileage is another criteria. You have four alternatives. Let's say similarly, you want to buy a house, size of the house, locality of the house, uh, price of the house, and different other public transportation or different. And you have house one, house two, house three, house four. Which one to select? Okay, so first thing first, you need to make this kind of hierarchy, and your goal is to select car or select a house or select boss or select a president or select objective that you have. Then criteria and then alternative. So if you make this clear, let's start the very first thing. Very first thing is called pairwise comparison. Pairwise comparison, let's say I compare Seattle and Spokane. These are the two cities. So let me show you. Can you see my Excel?
yes,
Okay, perfect. So for example, Seattle and Spokane. These are the two cities. Let me put little bit further. So the middle point is always one. One means they are equal. So basically, we are looking into the terms of weightage. So let's say population weight. So Seattle and Spokane. One is both are equal, means they are same size of population, which is not. So now this pendulum towards Seattle side makes, you have more weight. You can say like, weight. Where you are shifting means that is more weightable. So let's say I can say 1, 2, 3, 4, 5. And I can put here 2, 3, 4. Let me put this here. And 5. So the first step is to make a pair. Now this is equal, means both are weight, but this is not. If I know correctly, Seattle is almost 3 times bigger than Spokane. If this is correct, I can put this like little bit bigger. So Seattle is 3 times bigger. Then how I can say Spokane? Spokane as compared to Spokane. Seattle is 3 times bigger as compared to Spokane. Then what about Spokane? Spokane is 1/3 of Seattle. What is 1/3 of Seattle? So this is same. So I'm going to, so this is the situation. Now, if I compare, so basically, if I do the pairwise in terms of this, I put here Seattle, and then, Seattle, then second is Spokane, then third, which is the, let's say, Pullman, and here Pullman. So this is the matrix that I can develop initially. So Seattle to Seattle equal. So I will say 1, same. Now, as I said, we need to read from row Seattle to Spokane. So as I said, Seattle is 3 times bigger than Spokane. So I will put here 3. Now here you read this Spokane to Seattle. Here I put 3. Then what I will put here? Equal sign 1/3. Because Spokane is 1/3 of Seattle. So whatever is, so this is the value. What do you think the Pullman? Seattle is about maybe 5 times bigger. I don't know exactly. Seattle is 5 times bigger than Pullman. Then Pullman as compared to Seattle, 1/5 here. So which is now. Now Spokane to Spokane is 1 because Spokane to Spokane is 1. Pullman to Pullman is 1. Now we have one thing left, which is Spokane to Pullman. Spokane to Pullman. So Spokane is like twice of Seattle. Let's say is twice bigger than Pullman. So I can put 2. And automatically Pullman is half of Spokane. So do you understand this first matrix? To make criteria, it's called pairwise matrix. Based on the weightage. So if you do like this is the first, then life is very easy. Most of the students make mistake here, like reciprocal or, inverse. So for example, Seattle is 3 times bigger, Spokane is 1/3. Seattle is 5 times bigger than Pullman. Pullman is 1/5 of Seattle. So if you do this clear matrix, then very, very simple. Is it making sense? So similarly, selecting a new car, style, reliability, and so based on that, this is the matrix has been. So do you want me to do the banana case or do you want me to do this? So if I show you just a minute. So let me open the, do you want me to do the banana case or this, this car selection case? Okay, let me.
Banana.
Okay, because I want to make it easy so that you can have, uh, time saving in module fifth, sixth, sorry. Just a minute. Where is so review? Because I think recording already have. So this is the case. Can you see?
Yes.
Yes.
So what do you think now here, So here, one is, this is comparison apple and banana. What do you rate here? What do you understand from here?
Banana
Banana,
is 3 times greater than apple.
yes. So banana is 3 times more likely preferred than apple. Okay. Here, apple is 5 times, 5 times more likely preferred than cherry. And banana is 7 times more likely preferred as compared to cherry. Is it making sense? So you see 1 means equal, but wherever pendulum is there, that you can understand that is most likely. So I'm just going to put these numbers in the matrix. So
Where you eat? Let me go for my food.
is there any question? So let me make this as both screen together so you can see this. So I hope you can see my both screens. But the moment, so apple to apple is 1. Can you see Excel?
Yes.
Oh, why this? So apple to apple 1, banana to banana 1, and cherry to cherry 1. Now here I would like to say apple to banana. What should I put here?
A 3?
No,
1/3.
exactly. You can see this pendulum because banana is 3 times more. So here, as compared, here we have, oh, sorry, what is happening? So here, why we are putting 1/3? Because, so banana as compared to apple, here I need to put 3. Now, look into the situation. Apple to cherry. What do you say? What I should put here?
5.
Exactly, because apple is 5 times more likely preferred than cherry. So where is cherry to apple? This is 1/5. Now come to the last option. So what is banana? Banana uh, to cherry. What is banana to cherry? What should I put here?
7.
Yes.
1/7.
No. Banana, this we are reading. The reading should be in this direction. So, this direction. Sorry. What I did. I have to do this way reading. Means we read in this direction from row. So the banana to cherry. So look into that. Banana and cherry is the last this. Can you see this? So where is the pendulum?
Towards banana, so it's 7.
Exactly, it's a 7. Now what about this? It's 1/7.
Would it be 1/7 then? 1/7?
Yeah, so the same thing I did, 1/7. So same thing, it converts into decimal. So cherry, cherry is 1/7, as compared to banana. Is it clear? No. Yes.
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 Okay. So, it converts into decimal because, so first step is done. You know, so similarly, you have to do five, you have to make 5 by 5 matrix. This is 3 by 3. So in discussion, you have to do 5 by 5. Okay. Now let's do the second step. We need to do the normalization. What is the normalization? So let's say, the normalization, you have to make sum of n divide by. So I'm just going to make the sum normalization. So let's say, what is the normalization? Out of 100, let's say somebody is earning $40,000. 40,000, somebody is earning uh, $50,000, and somebody is earning $60,000. The total is 160,000, sorry, $150,000. So how I can normalize this? This is what percentage this is. So 40,000 divided by 150,000. So it will, and this will 50,000 divided by this much, and this will be, this is called normalization when you find the proportion of each of them. So this is 40%, this is 33%, and rest is this. The total is, you will see the sum of everything is 1. So this is 1. So basically you take proportion of each. So same thing we are going to do. We are going to take sum of each of them, is sum of each column, and okay, now we are going to normalize it. So how we are going to normalize? So I'm just going to do this same thing. Just a minute. And so how can I do that? I have to do this divided by the whole column sum. So I can know this divided by 4.2. And the third thing, point this divided by 4.2. Same thing I do for the second column, 0.3 divided by this, 1 divided by this, and this divided by this. The third option is 5 divided by 13. So basically we are doing a column operation. We are normalizing. So 1 divided by 13. We have normalized. Now we want to check whether, the normalization is correct. So we need to check the sum of entire column again, and it should be 1. Okay, this is correct. Sorry. If this is correct, now, so here, don't get confused. We are going to take the average of the row. Average, okay? Average of row. So equal AVG, and then I go and take the row. And then I do this, and then I just, can you see this? So now I find, 100 here. Now you got the weightage of, based on the apple, banana, and cherry pairwise matrix of people preference, we got first preference banana. Banana is 64% preferred. It's a criteria weight is 64%. Second is apple, 28%, and third is cherry, which is 7%. So this is basically in ranking, you can make, this is the rank 1, this is 2, and this is 3. So basically, if you want to do the ranking of your option, banana is here 64%. This is, second, this is third. So this is your first item, or first answer has been, this is called priority vectors or preference vector, or name anything. So for example, this is the same thing in this, and this is called priority vector. And if this is clear, we need to check whether our consistency of the matrix is correct or not. Because this is fine here, people up to here it's fine, but because of some error here you get here, but you how to check whether it's a consistent or not. Therefore we have, so look into the selecting a new car 100%, style is 30%, reliability is 60%, fuel economy. So basically the same thing in banana, apple, and cherry, we got the weightage. Now we have more thing here to, now we have different cars. But before going into car, we need to check the consistency, and therefore we are going to look into the lambda max and other things. So look into what is the lambda max. So first, we need, this is our original matrix. You might have studied, those who are mathematics or engineering background people, they have studied, this is A multiplied by X, you get AX. So when you get this AX, and then do it. So I'm going to do this because lambda max can be calculated using that method. So just a minute. So now I'm just going to copy this original matrix. This we have right here. Now and this is, so this matrix is A and this is X basically. So I'm just going to calculate. So basically I need to put this value here. So this is the first, because we are going to, and this I put here little, in order to check the consistency. But for your discussion, you can come up to here, you can find 5, ranking in discussion, number 1, number 2, number 3, number 4, number 5, and you can discuss and you can conclude. You don't need to go for consistency in this, but for few questions are there, therefore I'm just doing this. Okay, so this is A and this is X. Now what we need to do? We need to do the calculation of this. So we are going to multiply this value and each value. So here 1, and then I do this on the top. So I get this, then 3 multiplied with this, then third thing multiplied with this thing. Similarly, I do this part 0.33 and multiply with this. Then similarly, 1. Now the same thing I do with third column. So 5 multiplied with this and 7 multiplied with this one, and then 1 multiplied with this one. Okay. And this is the value. Now we do the sum. Here we did the average of the row. Now what we are going to do? We are going to do sum. Okay, so here we do sum. Please remember, don't sum of row. So I just do sum and I do for entire row. And now I get, can you see this? So this is, here we did average now, and this extra work we are doing to check the consistency. So this is called A. This matrix is A. This is X that we are doing, and this matrix is called AX. If I put here, like, sorry, so this value is, this is the result of AX. Now we have to do this thing. So please look into that. So if we get this, now lambda max equal to average of 0.9 divided, so this divided by this divided by this, and point, so all three, and then take the average. So whatever value we get, that is average of that. So our original value is this. So we are going to lambda max equal to, let me put these numbers here, average. So lambda max equal to, so this value divided by this value. Now same thing, this value divided by second value, and this value divided by, oh sorry, I made a mistake. This value divided by this value. So now lambda max is a average. So this is average of 3. So basically we need to take the average of this, average of all 3, and we got here. Can you see this? So basically this is the example that is there, and I already did in previous case, but here, so by default we are also getting for banana case 3.06. Now consistency index, so we got lambda max. Now we would like to check consistency index, and we would like to check, so what is the consistency index? Equal to lambda max minus n. We have 3 by 3, so 3 divided by n minus 1. So whatever we see, so look into CI. The CI, sorry, I did mistake. Is it correct? Okay. So CI equal to this minus 3, because we have 3 by 3 matrix, and then divided by 3 minus 1, which is 2. In other words, 3 minus 1. Sorry. Okay. And here we got consistency index is about 3%. Now, based on the last step is left. So basically, this is called Sati index. And for each number of metrics, this is the value which has been calculated and we can use. So consistency ratio equal to CI divided by, for 3, this is the 0.58. So let's see. So consistency ratio equal to this divided by 0.58 from the 0.58. And now look into this. So what we get, CR is less than 6%. So if this is less than 10%, our evaluation or our work is consistent. So basically I have solved, almost 3-4 questions related to the banana example, because, this is the solution right here. So consistency ratio is, it should be less than, or less than, where's less than sign? So this is the less than sign, and less than 0.1, in order to say whatever work you are doing, that is correct. So, And let me make it bigger. So this is correct, is less than 10%. This is correct. This is lambda max. This is lambda max. This is CF. Excuse me. This is consistency index and Sati index. Sati index is given in the slides. So for 1, this is 0. For 2, 0, 3, this, 4 is this. So you can do 5 is this, 6, and so on and so forth. So if you get this, means your these where we get. So these numbers are, this percentage or you ranking you find, this is good. This is second and this is 3. So you can say this is weighting 64%, this is 28, this is about 7, and this is correct. And this extra work has been done to check this is consistent. Now, if you have done this, okay, perfect. So the same thing, so here we have done this is correct. For example, in banana, let's say in car case, the same thing is done for pairwise matrix in terms of style, and then civic to civic, Saturn to Saturn, escort to escort, and look into whether civic is 1/4 as compared to Saturn. Saturn is 4 times more preferred in terms of style. Okay, similarly, escort is 1/4 preferred as compared to civic, and civic is 4th time preferred because you can see all these things. So their priority vector for ranking, for reliability priority vectors, all 4 options. Similarly, fuel economy, how, this is given basically civic is 34 miles per gallon, 27, 24. If you get this kind of numbers, real numbers, you can normalize them like I gave the salary example. So now you have the final scorecard. Means this is a style, this is reliability, and based on civic style. So civic style is 0.13, 0.24, this is for all civic, Saturn, reliability for civic, these are put here. Now your final step is there. How you can do? I don't know whether I can do here and on it. Okay. So look into that. You need to multiply this with each. Means each value you need to multiply point. So I'm just going to 0.30. Okay, this is 0.3. 0.3. I'm not able to write it proper. Look into only one. You multiply with this with 0.6 because the weight is this, and you multiply this with 0.1. And then add all of them. Whatever value you will get the value of your this civic car in terms of style, reliability, and fuel economy. The similarly Saturn, you multiply with 0.3. So basically here you multiply with 0.3 each of them. Here you multiplied with 0.6. Here you multiply with this, multiply with this value, multiply with this value, and multiply and add all to get the overall composite value. Or in question I ask what is overall composite value. So basically whatever value you get, that is the overall. So based on that, here this is just a minute. So this is like, this is style reliability of Civic, Saturn, Escort. This is the criteria weight. So overall Civic is 30%. So number one option, what is? This is the number one preference when you buy 35. Civic is second, Saturn is third, and Escort is fourth. So if you are going to buy, which one you need to buy? Because it has the best composite score, which is 35%. Second option, if you don't get this, let's say you buy a house. If you are going to buy, this is first choice, this is second, this is third, this is fourth. And this is how, if you have many options, different things, you are in dilemma, this technique is perfectly fine. And so basically, this is the final result. Here, this is the final result. Civic is 30%, Saturn is this. Now, based on that, let's say, for example, this is your house example. Oh, Hanna, I'm going to answer your question. Wait a minute. So this is, yeah, you have to do your own judgmental matrix, Hanna. For the discussion, what do you think from your understanding? You just think about yourself. It's all opinion. First, your perception uh, based on your perception, you make the initial. Let's say the banana example, you like banana more as compared to any other fruits or as compared to any other fruit which you get. So it's all individual perception based discussion, then doing the calculation. So for example, goal is to buy a house and you have three house options, but you have size, transit time, neighborhood, age of the house, yard area, and finance and different other factors. So based on that, you can do that, size, all, cross. So Hanna, you need to fill out, for example, what you want to prefer when you buy a house or when you do related to discussion. This is your own perception. Okay. And this is eigenvector, priority vector for size, and then, for size, you need to compare all three houses. House A has 5 times more size as compared to the B. A has 9 times more as compared to C. Yard area, A has 6 times more as compared to B and 4 times compared to C. So look into all, things, and based on that, the overall A weight is this much, B is this much, and C is. So basically, the B is your option. B is the first option, or B is the correct option. And this is the real story or real, work that has been done by US Department of something. Which drink is consumed more in USA? And based on coffee, wine, tea, beer, sodas, milk, and water, this is a perception based or based on understanding. This is the matrix, pairwise matrix. So 3, 4, 5, 7 by 7. And now look into that. So this is derived from matrix, and this is from statistics of some US statistics. Coffee is 17.7 and actually is 18%. Wine is about 2%, 0.01, and here is about 1%. Tea is about 4%. Here is also 4%. Beer is 11.6. Here is about 12. Soda is 19%. Here 18. Milk is 12 or 13%. Here 40. Water is 32 or 33. Here is also. So this is the real, based on some style, and this is based on. So how, sorry, how close results can be in this case when you don't have real data, you take the expert opinion or judgmental, pairwise matrix, and you can come to the conclusion based on this. Okay. So same thing is here, this is related to food consumption and, steak, potatoes, apples, soybean, and so on, so forth. And this is the result, actual and derived. Derived from matrix, derived from AHP, uh, AHP uh, work, which is 0.345. Upper is original one, and lower is So this is, AHP work, and this is real work. And the consistency ratio is, about 3%, which is less than 10%. So, excuse me. And like you want to select a CEO of your company, or you want to select employee of your company. So based on education, based on experience, based on, interview performance, think many criterias, and you have three CEO for your company: Mr. Clinton, Margaret Thatcher, and George Bush Jr. Whom you will select? And you want to select the president of the country. So this is AHP, and this is the application of AHP. Is it making sense? So, the homework is almost done, because I shared, most of the questions. Uh, Now we have another topic in this, which is called earned value analysis. And earned value analysis is, just a minute. So basically, it is very useful tool when you are doing any project. It gives you performance of the project. It is very helpful those who are into the projects and those who monitor and evaluate the performance of the project. So basically, you have to see three important things in earned value analysis. Can you see my slides of earned value analysis? So always see three things. In project, you have planned value. Means as per project planning, what is the value as of now? So basically here, this method is as of now analysis it can do. So basically, if you are doing a project, let me go and briefly cover this. So let's say this is one of the example. You have dashboard on your project, Microsoft project or anything. So you have Gantt chart in front of you. This is your time period in month, day, or something. Let's say today you decided to do earned value analysis. You want to check the health of your project, how or performance of the. So any particular day, you can check, you can just draw the line. Okay, today you want to see. So you need to do three things that day. Based on a document, what is the planned value by this day, how much work has to be done, what should be the value. So today, let's say the work by this time, 80% of work has to be completed as per plan. But actually, how much is done? Let's say actually only 50% is done. And third thing in that, today you can check also how much money has been spent or how much money has been invested so far. So basically, if you understand these three numbers, rest is very easy for you to do. So I'm just going to briefly give you one simple example here. So here, for example, how do you check plant value? So today, activity one needs to be completed. Activity B needs to be completed as of now, as per plan. Activity C has to be completed 80%. Activity D has to be completed 50%, 15%. So, so 18, this is complete. So basically, this is done. 10, this should be completed. 80% of 20, which is 16. And 15% of 40, which is, so total value, a plant value was 50. Earned value so far, how much work this is done? So we earned this. How much? 80% is done in this. So basically 8. So 18, 8. This is only 70% done, which is 14. And this is not done anything. So we earned 40. From your accounting books or accounting, performance or accounting or finance department, you can say how much money has been spent, and they said 45. Now you have all three numbers in front of you to do the calculation. And we do the same, one simple example based on the soda example. Here we have, this is the case that so here understand, 1,000 cups of sodas over 50 days. So what is the and a steady rate of 20 cups per day? That's 50 into 20,000. Each cups cost 50 cents. Total project is $500. Okay. And you want to check this and one particular day and to check what is the at the end of the day 10, 100 cups have been produced or made. Total money spent is $90. So we can understand the three numbers at the number 10 days. How much cup have, so 20 into, so 20 cups per day. Sorry, 50 cups per day. Sorry, if I'm correct, just I have to see. Yeah, 50. So, sorry, 50 days, 20 cups per day. So, what is we need to know three numbers. 20 cups per day. So, we have 10 days, which is 200. Each cost 50 cents. So, this is plant value. At number, what is the plant value? 100 on the day number. 150 cups are done. So how much? So this is plant value. What is earned value? Earned value is 150 into 50 cents. So 75. This is plant value and actual cost spent is 90. So actual cost, plant value and earned value, we got it. Now we do the simple calculation. Simple, just a minute. Okay. So basically the same thing. So this is plant value, this is earned value, and actual cost is $90. So schedule, so basically we need to check three things. Cost performance index. So basically this is cost performance. So this is 0.75 or 75 divided by 90. Or in other words, you can say this is earned value divided by actual cost. Earned value is 0.75 and actual cost is 90. So let me do calculation. Calculator. Okay, here we go. So we have 75 divided by 90 and we got 0.83. So, this is cost performance index. What is schedule performance index? Schedule performance index is equal to earned value divided by planned value. So earned value is 75 divided by 100 and we get this. Now based on that, you can do many calculations. You can check the performance of your project. So let's do just a minute. So So basically you can see the project budget was $500 and the cost variance, cost performance index is 0.833. So $500 budget, 0.833. So this project, if it goes with this same pace, same speed, instead of $500, you are going to spend $600. Schedule performance, so you are going to complete this work in 50 days. 50 days divided by 0.75. Instead of 50 days, this is going to complete in 66.67 days. But 50 days work, you checked at number day 10 and you see the this is going slow. You have these 40 days left. You can do management measures, you can do many, you can speed up, you can tight your team, you can ask them to work overtime in order to come within, not to go over budget, not to go over schedule. So basically this is, so any software of project management, Microsoft project, they give you all these, planned value today, what is the earned value today, and you can see from accounting what is the cost so far spent in your, so you can see is it going on budget, on time, and how many days. So $100 extra is going to be here, 16 days or 17 days extra. No one can afford nowadays extra time and extra cost. Time is also cost is also time. So this is another method that you can apply in your uh, professional place. So we have few questions related to that. I already solved major part of the AHP. Now I'm open for your questions. Any question, please feel free to ask. If you don't have, I would like to say all the best for exam and all the best for everything and all the best for, after MBA, because I think this is our last interaction. I only teach these two courses and I hope you had wonderful 3 months with me, more than 3 months, because those who did BADM 503 and 520 together, they are like, bored of hearing me and, doing uh, quantitative things. So I wish you all the best and most welcome if you have any questions. Okay, wonderful. Most welcome, Angie. Yeah, always you can approach me if I can be any help. Can you just list the advanced thing that we can learn, Atul? Yeah, we have business and data analytics courses with us. Yeah, actually many things are there in the field. But these are the popular things. You can approach me in the email. We have business analytics. You can be, you can get the certificate and you can get also specialization into that. So it's all up to you. And we are developing more content that can be easy to apply.
Okay. Yeah, I'll surely reach out to you.
Yes. Thank you so much.
Thank you.
Most welcome. Bye-bye. Good night.
Thank you, Professor.
Most welcome, sir. And you will see this this work, uploaded in few minutes. Thank you.
Okay.
Thank you, Kevin. Thank you, Scene. Thank you, Jennifer. Bye bye. Good night. All the best.